matter, right? Yes or no?
Yes,
You guys
sir.
remember this? Okay. So I hope you guys have read that lecture, the notes of that lecture. Yes or no? No.
Yes,
Or
sir.
yes. Yes. Okay. So write a question. Okay. Write a question. What is the boiling point? What is the, rather I should say, what is the correct order of boiling point? What is the correct order of boiling point? Samaira, did you send Zainab the first lecture?
Yes, sir.
Okay. What is the correct order of boiling point of the three? Zainab, did you read it? Yes, Zainab. Zainab to thi kahan chali gayi? Acha. She must be joining again. She gets disconnected. I don't know why. Okay. Three isomers of pentane. Isomers of pentane. We have pentane, 2-methyl butane, two-methyl butane, 2,2, dimethyl propane. Or the order will be pentane, 2-methyl butane, 2,2, dimethyl propane, or rather it will be pentane, 2,2, dimethyl propane, followed by 2-methyl butane. By this question, है ना? All right, also the option none of these. Giving you guys 2 minutes. है ना? Write this question, giving you guys 2 minutes. Then we will explain this. Okay. I hope some of you give me the right answer if you have read that chapter, the first lecture. I think we have discussed the boiling points and all, right? In that section, yes or no? I hope. I think I did. Intermolecular forces of attraction, boiling point is inversely proportional to the intermolecular forces of attraction. Write this down.
No, you didn't explain last class.
Huh? Boiling point तो नहीं पढ़ाया था हमने, but in that first lecture, states of matter first lecture.
Yeah, yes, sir. Yes, sir.
I'm giving you guys 2 minutes. I'm not hoping for an answer, okay? But it will be very good if you give an answer. One thing I'm sure that you will understand the reasons. Okay. No answer. I think I need to explain this, okay? So if I go to that chapter, What I have written here? Boiling point is directly proportional to intermolecular force of attraction.
Intermolecular force of attraction.
Intermolecular force of attraction. Okay. Okay, Khalid. We will see. Now let me move to intermolecular forces of attraction. है ना? Now, first thing is that first of all we check that when we wrote that, compare the boiling point. So we will see whether it is polar or non-polar or what kind of substance is it. So if I look at this molecule, all of them are non-polar. Yes or no? All are non-polar. Nahin? Yeah. What do you think? Can you see all are non-polar or polar? Can you distinguish? Yes or no? First tell me that.
Yes, sir.
Why? Why are they non-polar? Why are they non-polar? Tell me. Which of them is polar, A or B? Which is polar?
B.
B is polar, na? Polar means it should have dipole moment. Dipole moment कैसे होगा? जब यहाँ पे delta positive and here it will have delta negative. Electronegativity difference should be there, right? So in this cases, pentane, all of these are hydrocarbons, and since only carbon and hydrogen is present, that is why all of them are non-polar substances. All of them are non-polar substances, right? Yes or no?
Yes.
Okay, I hope everyone is on the same page. All of them are non-polar, and the IMF in non-polar is what? Is the London forces? Yes or no? London forces or the van der Waals forces, right, guys? Dispersion forces. Okay. Now we will see what are the factors that affect the dispersion force. So again, you need to flip pages like this. And this is how learning happens. You need to flip pages here and there. You need to go here and there. So hydrogen bonding is here. Now see London forces. Okay. Now factors affecting van der Waals forces. We said about size, number of electron and molecular structure. So I know that the size of all of these will be same because we have isomers of pentane. We have 5 carbons, and then we have how many hydrogens? We have 12 hydrogens, right? So the number of electrons and the size, all of this will be same. The molecular structure is different with isomers, correct? The structure is different. Yes or no? Yes or no? The structure is different, guys. अब बताइए देखिए. I've written here. I've written here that this is the size here, and if I increase the size, then if I increase the branching, then what happens? The size is going to decrease, even though we have same number of carbons and same number of hydrogens. So this has more size, and if it has more size, then what is going to happen? If it has more size, the electron deformity will increase and the van der Waals forces will increase, right? So you can write a direct relationship that intermolecular forces of attraction, it is inversely proportional to branching. So what will happen if the branching is increasing? Intermolecular forces will decrease. Intermolecular forces will decrease, right, guys? So we have 3 structures. This is pentane. This is 2-methyl butane, and this is 2,2 dimethyl propane. So I can say in this way the branching is increasing, and that is why intermolecular forces will decrease. And if the intermolecular forces decreases, the boiling point decreases. So the boiling point order will be pentane will have the highest, followed by 2-methyl butane, and then followed by the next one. Wait a second. Sorry. Okay, so all of you understood this? Yes or no? Tell me.
Yes, sir.
you know not to look, you know that you have to look at the branching. So pentane will have the highest boiling point, followed by 2-methyl-butane, then followed by 2,2-dimethyl-propane. Branching is inversely proportional to intermolecular forces of attraction. You don't need to write all these things, and if you're writing, then it's fine. But I will be giving you the PDF, then you can complete if there is some gaps and all. Right, next, that is the preparation of alkenes. Preparation of alkenes. In preparation of alkenes, first method is hydrogenation of. Hydrogenation means reaction with hydrogen, H2. Hydrogenation of unsaturated hydrocarbons. So if you have a molecule such as CH2 with a double bond CH2, and you add hydrogen to it in the presence of a catalyst, the catalyst may be PD, PT, or nickel. Then what happens? The hydrogens, they add to this particular double bond, and you will get CH3 single bond CH3, CH3 single bond CH3. Okay. Then if you have, for example, any R group attached here, any R dash group attached here, there's a double bond. You add H2 in the presence of any of these catalysts, then what you are going to get? You are going to get, as it is, there will be one hydrogen added. Okay, so the new hydrogen that I'm adding, I'm just writing that in different color. Okay, in different color. And obviously here also there were hydrogens, right? So those hydrogens are here like this. Okay, so simple reaction. What is happening? If you are reacting this with H2, the pi bond is breaking, and each carbon is getting a single hydrogen atom. Right, next. Right, next, that is some remarks. Okay. First of all is this. Now, since we are using a catalyst, it is also known as catalytic hydrogenation, aka catalytic hydrogenation. Catalytic hydrogenation. Secondly, since you know what we are using unsaturated hydrocarbons. So there should be at least double bond or triple bond between carbon and carbon atoms. There should be double bond or triple bond between carbon and carbon atoms. What does it mean? It means that I cannot prepare a bond, I cannot prepare an alkane in which there is only one carbon atom. The limitation is what? Methane cannot be prepared. Limitation is methane cannot be prepared by this method. Methane cannot be prepared by this method. Okay. Write the products of following. Okay, so write the products. Wait a second. Wait a second. I did not write one component. H2 नहीं लिखा हमने. I just need to add H2 here also. Wait. Yeah. Hydrogenation. So H2 will be added. Yes. Now write this. Just add one more reaction. Cyclic भी आपका आ सकता है. Okay, Hishma. If you want to write Hishma, you can write in the chat. That's okay. But even if you don't, okay, fine. Write the D1 also, okay? Done, guys? Yes or no? Done? What happened, guys? Hamza, Hiba, Khalid, Matthew, Sarah, Samaira. नहीं हुआ पूरा है क्या आप लोगों से?
Yeah. Yes, sir. Yes, sir.
Done.
I think I'm done here.
Done, na? CH3, CH2, CH3. Simple alkanes, right?
Yes, sir.
The next one will be
The double
CH3.
bond will go.
Yeah, just the double bond will go, and you will have to add hydrogens here, right?
Yes, sir.
Wherever you are removing the double bond. CH2, CH3, and here you will get CH3, CH, CH3, CH2 double bond. Sorry, CH2 single bond, CH3. And in this case, you will just make a cyclohexane. The double bond will go. Okay. No problem, guys. Any
No
problem,
problem.
guys?
No, sir.
No
No,
problem.
sir.
Okay. Right, next. This is how we are going to prepare if we have simple unsaturated hydrocarbons. Okay, simple unsaturated hydrocarbons. Let me also give you an example. If we have the triple bond, so in triple bond, what will happen? CH3 single bond, CH, it should be only C, CH. So you add H2 in the presence of, let us say, PD or PT, anything. Okay, you added H2. So first it will make CH3, CH, double bond CH2. And so one hydrogen molecule has been added. Right? So like this, one molecule has been added. If you do same reaction one more time, then you will get CH3, CH2, CH3. So in total, you have CH3. If an alkyne is there, CH, then you will need 2 moles of hydrogen. And then there will be some catalyst, PD or PT, and you will be getting CH3, single bond CH2, single bond CH3. Okay. So not much difference, only 2 molecules of H2 because we are doing addition 2 times. We are doing addition reaction 2 times. Okay. Next, we'll understand about alkyl halides. The next is from alkyl halides. Okay, preparation of alkanes, and we are writing this in black only. No, need to change this, not black. From alkyl halides. Okay, what are alkyl halides? Alkyl, we have alkyl which has halogen attached to it. So it is represented by Rx. And Rx, X will be any halogen. X will be any halogen. X is equal to chlorine, chlorine, bromine, or iodine. This is alkyl halide. So from alkyl halide, we have the first reaction that is known as the Woods reaction. The Woods reaction. In Wood reaction, what happens? You will take alkyl halide Rx in the presence of sodium, and this should be in dry ether. That means there should be no water. Okay, dry ether, no water should be present, and you will be getting an alkene with double the molecule, with the double the number of carbon atoms as in haloalkane, RR plus NaX. Now just to make it balanced, we'll write 2Rx, and it is going to give you RR plus NaX. Some examples of this reaction will be CH3. If you have fluorine, oh, sorry, not fluorine and chlorine. Eliminate. The easiest examples would be, practically it will be CH3, Br plus sodium. So in the presence of dry ether, okay, so De, this is dry ether. So what I will be making, CH3 will have a bond with CH3, okay, and you will be getting NaBr. NaBr. So I'm giving you some simple examples. You will write it, okay. So you will have CH3, CH2Br plus Na, presence of dry ether. Similarly, you can have CH3, CH2, CH2Br, sodium in the presence of dry ether. So what will be the product? So tell me, how many carbons will be there in this product? How many carbons?
3.
Okay, how many carbons are here in the haloalkane in this second example? How many carbons are there?
1 carbon.
1 carbon. And in the product, how many carbons do we have?
2.
2 carbons. So it is doubling, na? We'll
Yes.
have double the number of carbon atoms. Okay. So what will be the product here, guys? Can you name it? 4 carbons. What will be the product? 4 carbons. What will be the product?
Butane.
CH3 single bond, CH2 single bond.
Butane बोल दीजिए Khalid.
Oh yeah, butane.
Yes, CH3, CH2, CH2, CH3. And ignore this inorganic product. We just want the major product, that is the organic product. What will be the compound here in the last reaction that I have written? What will be the compound? Cyclo काहे से हो जाएगा भाई? Hexane हो जाएगा ना? It will be just hexane. Why cyclo? Huh? Not cyclo. Okay. Simple hexane. CH3, CH2, 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 1, 2, 3, CH2 and CH3. Okay, I think Heshma, you said no? Cyclohexane. Who said?
Yes, sir.
And so it will not be cyclohexane, it will be simple hexane. Okay.
Okay, sir.
So alkyl halide.
Sir, by the way, we don't have to include NABR.
I mean, examination में time मिले तो कर दीजिए include. Otherwise, generally it is not included. The inorganic product. We are only interested in the organic molecule that has been produced. Okay. Alkyl halides, when treated with sodium in the presence of sodium, in the presence of dry ether, leads to formation of alkane with double the number of carbon atoms, double the number of carbon atoms, with double the number of carbon atoms. Okay. So now next thing is that if you have simple alkyl halide, then it is going to be very easy. Okay, it is going to be very easy. Now let us see what is happening. We have sodium. Okay, we have sodium. Then what it is going to do? Sodium is going to get sodium positive plus an electron. Yes or no? Plus 1 electron. Okay, sodium positive and plus 1 electron. Then we have this bond CH3, CH2, and here we have Br. Here we have Br. Now this is an electron. Here we have delta positive. Here we have delta negative, right? Delta positive, and here we have delta negative. And here we have sodium. Here we have sodium. So what happens? This bonds breaks like this, giving you CH3, CH2, and a free radical plus Br with a free radical. Okay, Br with a free radical. So now Br has how many? So Br initially it had 1, 2, 3, 4, 5, 6, right? We had how many? 3 lone pairs, and now it has Br has 1, 2, 3, 4, 5, 6, and there is 1 electron here. There is 1 electron here, right? Now what will happen? There is sodium positive, right? There is sodium positive, and there is an electron that is here. The electron that is here, and what will happen? This electron will combine with Br, and this sodium will combine like this, and it will be forming NABR. So this is the formation of NABR. Now what happens? This reaction, it happens 2 times. So you get 2 of these molecules. You will get 2 of these molecules. Then one of the CH3, CH2 free radical. Then you have CH2 free radical and again CH3. Now both of these, they interact with each other and they form bond. So you're getting CH3, CH2 combined with CH2 and CH3. Okay, and CH3. Now very important thing is that this CH2 and this CH2 is the CH2 which was bonded to halogen. Okay, the halogen with the carbon which had halogen is the one which is forming bond. Okay, bond is formed between carbon that had halogen attached to it. Okay, now this will give us an information. What will happen if I react Br 2 times the presence of sodium, presence of dry ether? What will happen? So there will be 2 things like this. So we'll make it like this, and this is going to be the bond formation between when you have bromocyclohexane, right? This is what? Bromo cyclohexane. Right. So what we are making here, we are making dicyclohexane. Hai na? So two of the cyclohexanes, these are combining. These are combining together. These are combining together. So this is the carbon atom which is getting reacted and it is forming bonds. So let us write a few more examples. When you have CH3, CH, CH3, and this carbon has a Br molecule. This carbon has a Br attached to it. So I will take two of this in the presence of sodium and dry ether. Then what is going to happen? So what you will write it like this: CH3, single bond CH, single bond CH3. Then make again same molecule CH3, single bond CH, single bond CH3, and just make a bond between them. Okay, just make a bond between them. Any problem, guys? Tell me.
No, sir.
No. So I'm giving you some examples. If you have two molecules of and see, important thing is that you write the structure no matter how ugly it is looking. Okay, don't care how ugly it is looking, it should be correct. It may be ugly, it may seem very weird, but it should be correct. An important thing is that they will be asking you the name, so you can obviously write the name here, right? So you'll take these four carbons and this will be 2,2-dimethyl. Yeah, so this will be 2,2-dimethyl butane. Right, for the next one, draw the structure for the next one. Done? Yes or no? For the second structure
Wait,
done,
sir,
guys?
wait, sir. 1 second.
Wait. Keep things simple, okay? एक बार ऊपर बनाइए, एक बार नीचे बनाइए, और जहां पे wherever you have the bromine attached, just join those two carbon atoms. Done, all of you? नहीं हुआ अभी तक? Oh my God. Hamza, Hiba, Khalid,
Sir, done, sir.
Samaira,
Done, sir.
done?
Done, sir.
You?
Done, sir. Yeah, I said done.
Okay, you said done. Okay. Try naming it. Try naming it. Tell me 2,2 dimethyl. 2,2 dimethyl.
Butane.
Butane. कहाँ से butane? This is main chain.
Hexane.
Hexane. Okay. All of you agree with the name? Yes or no?
Yes, sir. Yeah.
Okay. 2,2 dimethyl hexane. Now, again, one more thing that you can obviously see is that I can only make even number of alkenes from this method, right? Yes or no? Tell me.
Yes.
Anna, I cannot make any odd number because in the reaction itself we are saying that the product that will be formed, it will have the double the number of carbon atoms. So if you take any alkyl halide and you double it, it is going to be an even number. So the first limitation of this is that first limitation will be we can only prepare a short में लिखते हैं only even number of alkenes can be prepared. Okay, next thing, it gives mixture of alkenes when two different RX are two different alkyl halides are used. What does it mean? It means that, for example, I took CH3 Br and I took CH3 CH2 Br in the presence of Na in dry ether. So see, this alkyl halide can go on its own reaction with sodium and dry ether, and it will be forming CH3 CH2 CH2 CH3. And this alkane halide will be on its own reaction because some of the CH3 Br will also be getting colliding with each other, and they will be forming CH3. But there will be some times when these two will react with each other and they will be forming CH3, CH2, and CH3. So even though we are forming an odd number of alkene, here we are getting a mixture. And since alkenes, these are non-polar and they have a very little difference in their boiling point, we can't separate it. Okay, we can't separate it. Next is, so this is two problems. First of all is that we can't prepare an alkene with odd number. If I try to solve this, then I'm getting a mixture of alkenes. Is this point clear with everyone? Yes or no?
Yes, sir.
Right? All of you? Yes, guys?
Yes.
Sir. Yes, sir.
Okay. Yes. Next, we have one more method of preparation, that is from alkyl halides only. But in this method, this is the first method. Second is, what did I write? A or B? A. Reaction with zinc in H+. That's mean in acidic condition. We are putting zinc in acidic condition. Okay. So in this case, what we will be getting, we'll have. First thing is that reaction of what? Reaction of alkyl halide only. Okay. So we are doing alkyl halides. So we will take any of the alkyl halides. Just take Rx. The presence of zinc and H+ acidic condition, you will be getting RH. And other product will be HCl or HX. You can write, or you can write HX. Okay. In this case, X, it is equal to chlorine, bromine, and iodine. Okay. So alkyl fluoride, they don't give this reaction. So this is a typical reduction reaction. This is a type of reduction reaction. Okay. So you can write some examples. CH3Cl. In the presence of zinc, it is going to give me CH4 plus HCl. Similarly, CH3, CH2, Cl, presence of zinc and H plus, it is going to give me CH3 plus HCl. Okay. So this is also a simple reaction. No problem with this, yes or no? Right, next,
No, sir.
from carboxylic acid. Achha, I gave you time to write. Other I should not give you time to write. Right, next, that is from carboxylic acid. From carboxylic acid. First type of reaction from carboxylic acid is decarboxylation. Decarboxylation. Decarboxylation reaction. So when you have a sodium salt of monocarboxylic acid, when sodium salt of monocarboxylic acid, sodium salt of monocarboxylic acid is heated with soda lime at around 630 Kelvin, then alkane is formed. Then alkane is formed. So you will have any carboxylic acid, but monocarboxylic acid. It means there should be only one carboxylic acid group in the substrate, COO-Na, sodium salt of carboxylic acid, plus soda lime, simple NaOH, in the presence of, is heated around 'Okay. So what do we have? CH3COH, and then we have the soda lime, NaOH, and NaOH and calcium oxide. This is soda lime at around 630 Kelvin, and you are going to get RH. So simply, if you have CH3 COOH plus NaOH, you can also see sometimes like this, CaO at 630 Kelvin. So this complete carboxylic acid will be removed, and you will be getting CH4. You will be getting CH4, and the byproduct is N2, Na2CO3. Na2CO3. We'll write some examples. So this is a very good reaction if I want to prepare NaOH in the presence of CaO at 630 Kelvin. So we'll just get a cyclopentane. Just get a cyclopentane here. Instead of COH, you will be attaching here hydrogen. So at least one of the carbon, it should be one less carbon than the carboxylic acid. Okay, this will be simple propane. So you are starting with butanoic acid, and you are getting propane. Any problem till here, guys?
No, sir.
No. Okay. So next is coal-based reaction. Same thing, carboxylic acid. Using carboxylic acid. Next one is coal-based reaction. Coal-based reaction. Now, in this, what happens when an aqueous solution, of sodium or potassium salt salt of carboxylic acid is electrolyzed, then alkane is formed. So the reaction that happens, the overall reaction, if I want to write the overall reaction, then in that we will have the sodium salt, right? Then we will have the sodium salt, and we are going to electrolyze it in the presence of water. So we have CH3, COO, Na, sodium salt of carboxylic acid, plus I'm adding what? I'm adding water here. I'm adding water, and after electrolysis, it is going to give me, after electrolysis, it is going to give me CH3. Then we have sodium, right? We have sodium and we have water molecules. So obviously I'm going to get sodium hydroxide plus CO2 and hydrogen gas, plus CO2 and hydrogen gas. So this is the basic reaction in electrolysis. This is what happens at electrolysis. Now in electrolysis, you have to remember a few things. Okay, there is anode and there is cathode. I know that electrolysis is not in your syllabus till now. It is not there in your syllabus till now. Okay, but right, you have to write, and you will have to remember these points: the reaction at anode and reaction at cathode. Reaction at anode. Reaction at anode. So in anode, what happens? Whenever you will have anode, then there will be oxidation taking place. So what do we have? We have, in this complete reaction, we have COO negative and Na positive. These are two things. So we have CS3, COO negative. What it will be doing? 2 moles of this. It will be giving out 2 moles of electron. Because what is oxidation? Oxidation can be loss of electron also, right? It will be loss of electron. Then it will be forming CS3, COO neutral, which will be very unstable. And then what is going to happen? You are going to form a CS3 molecule. We are going to form, this will be again 2. So you'll be forming 2 moles of CS3 free radicals. And then you can see there is what? COO. And it's COO to form CO2, 2 moles of CO2. So this is the reaction that is going to happen at anode. And this will be a what? This will be a oxidation reaction. So you can see that CS3 and CS3, 2 moles of CS3 free radical, they are going to attach with each other, and they are going to form CS3. Then we have cathode. Reaction at cathode. In cathode, there is always going to be reduction. In cathode, what happens? In cathode, always there is reduction, and the reduction will be of water. So you'll write H2O plus electron, H2O plus 1 electron, What it is going to give you? It is going to give you OH negative plus a H free radical. Then this will happen 2 times. The whole reaction will happen 2 times. At 2 OH negative, you'll get 2 H free radicals, and 2 H free radicals is going to give you H2, which is getting produced as the product, which is getting produced at the product. So at anode, what happens? Oxidation, removal of electron, and cathode, there is reduction, and that leads to what? And that leads to reduction is gain of electron. Okay, gain of electron. So you have two species, CH3COO negative and H2O. So obviously CH3COO negative is going to give out electron because it has more electrons, and water is going to eat up electrons. Okay, eat up electrons. So this is one method. Now I'm going to give you some examples. You will just write the product. So also here you can see there is double the number of carbon atoms, right? Double the number of carbon atoms. We will write the major products. COOK, and let us write plus H2O, and there is electrolysis. So what we will be forming? We will be forming CH3, CH2, CH2, CH3. Similarly, if I have something like this, the presence of electrolysis, so this, and one more time you will write the same thing. So this is the carbon, this is the carbon which had COH, you will just join them. Okay, we'll just join them. This is the product, this is the alkane that you are going to get. So this will be 1, 2, 3, 4, 5, 6. So this will be 2, 2 dimethyl hexane. Here also, this carbon atom was the one which was reacting. So the bond will be formed between those two carbon atoms. Okay. Okay. Write some homework questions. Okay. So you have to write what will be the reagent used here. Okay, what will be the reagent used here, and I'm going to form CH4. Here you have to write what is going to happen here in the B, and I'm going to form CH3. CH3. What will be the product form? Okay. So write these questions. Let me know if you're done.
Done, sir.
Done, all of you?